In order to learn the routine, we need to actually see what's routine. So we're going to experience it again. I'm going to try, that's my turn, right?
Yeah.
We are going to practice together looking for calculation shortcuts using what you know already about the way area and multiplication work. And we're doing this because we want to learn to think like mathematicians. We want to learn how to use mathematical structure to simplify and organize our thinking. 4 steps, probably noticed them last time. There's the noticings, right? That's the flashing of the image. You work with a partner to find a shortcut based on the structure that you see, maybe more than one shortcut. We're going to share and study some of those shortcuts up here. And then at the end, we're going to reflect on what we've learned. The goal of reflecting, by the way, is to try to come up with a generalization. Not, how do I solve this problem? But how do I use what I learned on this problem to solve other problems? Because if the only problem you learn how to solve is the one that I give you, I have failed you, right? You have to be able to generalize. So we're going to flash an image. I'm going to ask you again, think about what might be mathematically important about the image. And Caitlin, I thought, put it up there for a really long time. I'm going to really like cut it a half or quarter of the amount of time it's up there. It's going to be very, very brief. We could potentially notice everything. I would like you guys to try to think about the pieces of what we look at. Okay, does that make sense? Okay, ready. 3, 2, 1. Think about what you saw. All right, turn to your partner and share something you noticed.
So it's definitely a rectangle. Faux show.
All right, let's draw together as a group.
You're right.
Why don't I take noticings from each table? So somebody at this table would like to share a noticing?
There was a rectangle.
Rectangle, great. Great. Something else?
The measurements were 15 and 24.
Anything else to add?
The width was 15 and the length was 24.
So you're doing these things areas. You're connecting them to width and length, right? What else did we notice? Maybe, now that we've got some detail here, what do you know about this information that would be helpful, potentially?
This can help me to find the area of the rectangle
So you're thinking about, am I going to be looking for an area?
or the perimeter.
Or perimeter, maybe? So you're thinking what kind of question this might be? What about these numbers? Is there anything about these numbers that might be helpful to notice?
They're both multiple.
Oh, so numbers are both multiple of 3. Anything else? I abandoned my one person per table thing, sorry.
This is probably not a stupid comment, but.
Do you notice something else about the numbers? Go ahead.
Well, we noticed that, is it a rectangle if we don't know that the angles are 90 degrees?
Oh, so we have a geometry teacher question. Great. Clearly somebody's in the middle of teaching 10th grade geometry, right? Or 9th grade geometry. Super. Okay, so we're going to move on. It is a rectangle, and we're going to try to find its area. In our heads, without writing anything down, without pulling out our calculators, we're going to try to find the area of the rectangle, and you are right, those are the dimensions. So we're going to try to use those numbers somehow efficiently to find the area of the rectangle. Take a moment and think about it. Okay, so now work with your partner, develop a strategy or shortcut to efficiently find the area of this rectangle in your head without pencil or paper, without a calculator. If you come up with one strategy, see if you can come up with a different one that's better, it's more efficient. Okay, go ahead.
Broke down into two, so that's 22. And if you put around by 5, so I know that if I multiply 20 by 10, that will be 200. And then when I multiply 4 by 5, which is easy, that will be 20. And when I add it, that will be 220.
Yeah, because I always look for zeros.
Do you think the area is 2.5?
That was good. You took my idea.
Oh, great. Would you mind sharing it together
I
maybe?
broke it up to 15. I broke the 15 and so I translated the 10 times 24 is 240. And then
I think they teach, I taught that, I think, in
and then
5th grade math. They learned partial products and all of that stuff to help, because zeros make multiplying easier.
I think you were splitting it into 4 rectangles, but you ended up calculating 2 rectangles, and you left 2 of them out.
Did you split into 4?
yeah,
Can you tell me how you did that?
Yeah, I realized that it's 24, right? So
Yeah.
I did, since it's easier for me to multiply when you're in the
I
20s,
just,
Yeah.
I did 20 by 20 plus 4,
Uh-huh.
and I did that 20 by 5.
Would you mind sharing your strategy?
so what do you guys do?
Super. And, what did you think?
I just split the 15 into 10 and 5, and then I knew that 5 is going to be half of the 10, and then just arbitrary
Both of
value.
you sharing strategies. Great, that's very different.
High school.
All right, let's try together as a
Make sure
group.
that you get 4 of them, because I think it's a good strategy.
So
I thought there were 2 numbers that in my head.
So we're going to be sharing our strategies and trying to see what's similar and what's related in these different strategies we've got. And if you're presenting, will you try to use the sentence frames here? We noticed, so we knew, so we, or our strategy works because. That may be a critical one. And then if you're in the audience, will you listen for what they're saying using the same sentence frames and be prepared to restate? We're good? I am going to try to draw with my hands while the first person presents, okay? And then that'll help you track what they're talking about. Will you, one of you two, share your strategy first? Is that good? Go ahead, Tammy. Okay.
So what we did, what we noticed was we like numbers that are easy to work with. So we took the 24 and we broke it into 20 and 4. And we did 20 times 15, which gave us 300. And then we did the 4 times 15, which gave us 60, and 300 plus 60 is 360.
Can someone restate that strategy? I see your hand. I'm just waiting to see if there are more. Go ahead.
They decided to take the 24 and break it into 20 and 4. Get like 2 rectangles. And 15 times 20 gave them 300 for that rectangle. And
Yeah.
then they did 15 times 4, which is 60. And they added together the 300 and the 60 to get the total.
Can I, how do they know that this was 15 by 4?
Well, they changed the length by splitting it into 2 pieces, 20 by 4, but the 15 didn't change.
Got it.
So the width still has to be 15.
So this length here is the same as this
Yes.
length here. So they're, right, see that? Great, so then they added those 2 things up. Does that represent your thinking? Yeah? And then we added this piece, I think, about where the 15 came from. Great. Let's get another strategy. I saw somebody who had divided it differently. I think it was, David, would you go first? No, actually, I'm trying to decide now. David, let's do yours. I think it's really close to this one in a way. So let's try yours first.
Yeah, so what I also know is that I'm not very good at when the numbers are very large. I try to break it down to make it easier for me to calculate. So I broke the 24 by 20 and 4. And because I'm good at multiply tens. And I also broke the 15 by 10 and 5. So that I will get 4 sections. The same triangle is broken into 4 sections. And then I can do the multiplication by 10 by 20, that will give me 200. And then I can also multiply 10 by 4, that will give me 40 over there. And then I can also take the 5 by 20, that will give me 100. And I can also take the 5 by 4, that will give me 20. So when I add all of them, I'll get 200, 40, 20, and 100, and that will give me 360.
Super. Can someone restate that strategy? I'm gonna go with Tammy, okay?
What David noticed was he doesn't like to work with numbers that are really big.
Yeah.
So he broke up the 24 into 20 and 4, and then the 15 into 10 and 15. 10 and 5, sorry. And then he multiplied the 10 times the 20, which gave him 200.
Okay. Hang on, I wanna, oh well, I guess I'm gonna have to get another color. Okay, so 10 times 200.
10 times 20 is 200. And he did 10 times 4, which is 40.
And again, how did he know that it was a 10 here?
Because the limb stayed the same on both. He just cut it in half.
Yeah, this
Well,
length.
not half, but into 2 pieces. So
Yeah.
it shares the same length as the other part.
Okay.
He did 5 times 20, which is 100.
Yeah.
And then he did 5 times 4, which is 20. And then he added up all the parts. 200 plus 100 is 300. And 40 plus 20 is 60. So 300 plus 60 is 360.
And if I recall correctly, I heard that he added them in this order. Like he kind of went around like this.
I think that's what I heard.
Yeah. Any questions? Does this represent what you were thinking? Any questions about this? Why does this work, by the way?
You want me to answer? Or?
Oh, anybody. Kid, what do you think? Why do you think this works?
Because he's not taking away or adding in any new area. He's just splitting up the rectangle into the 4 pieces that make it up.
Got it. So we're conserving area. We're not changing the total area. Adding area together is no problem. Great. Do you want to share your strategy now?
Sure. I like the number 15. I think it's special because 5 is half of 10, and 5 plus 10 give you 15. So I split that side into 10 and 5. And 10 times 24 is just moving the place value, so it's 240. And 5 times that is half of what 10 times it was. So I just took 240 and divided it by 2 and got 120. And then I thought about 120 plus 240 as 12 plus 24, which is 36. And so then I realized it was times 10 and made it 360.
Super. Can anyone restate Kit's strategy? Go ahead.
Like the number 15, because it splits into 10 and 5, and 5 is half of 10, so we split that side into,
I want to write that. This is going to be in critical later, right?
right,
Yeah.
so we split that side into 10 and 5.
Okay.
And then he knew that 24 times 10 was 240, because you just add the 0.
I just want to come up here. Just add Yeah,
And then he knew that since 5 was half of 10, the area of that bottom rectangle is half of the top. So it was gonna be 120.
so I almost wish I had done this one in red. Hold on. So he divided that by 2, yeah,
Yeah. And then
Okay.
he just added those together.
yeah, and he did something tricky with adding these two, do you remember?
No.
Anybody remember, he did something fun, yeah, what did he do there?
24 plus 12
Yeah, he
first,
completely ignored the zeros,
and
right?
added the 0 afterwards.
So he went 24 plus 12, right? And that gives you 36. And then I would say he remembered this fact, right? When he thought 360. Cool. Does that represent your thinking? Super. So now let's reflect on what we learned from this. There's another spot in your booklet to record. Take a minute, write a response to either one of these two prompts. Oh, those prompts are not correct. Excuse me? Here we go, new prompt. Better prompts. That may or may not give you a clue as to something that changes. Feel free to share what you've got written with your partner.
Define purpose to find area by breaking down the rectangles into smaller, easier to work with rectangles.
Smaller areas to get the total.
Here and then it's one side.
We also said that it's going on by so much because of 3. If you do it's going
All right, let's draw together. I've got a couple reflections I want to start us off with.
between numbers.
Would you mind sharing your reflection first?
Sure. You can find shortcuts to find area by using partial product and then adding all the products together.
So find partial products, add them together. Where are some partial products that we use? Would you mind giving some examples?
With the one we did, so you would take 20, well 24 we broke it up into 2, 20 and 4. So the partial product would be 204. And for all the 4 parts in which we found the product, you take those products and you add them together to get the area.
So here are our partial products. And you're saying this plus this plus this plus this gives us area.
Total area.
And we discovered that that works because we're not removing the area.
We're adding
We're adding new area in, we're keeping the area constant. What do we here? Partial products? Right? And then here, it looks like we actually use that strategy every single time. Pretty important to remember. Okay, another reflection, Maxine?
You can find shortcuts to find area by using place values to split up large numbers and multiplying and adding them.
Can you give me an example where we use place value?
So 24 is 20, which is in the tens place, and then 4, which is in the ones place. So
Right.
that's inconsistent with the first two.
Yeah.
And then the
Especially.
last example, I think we split up 15 into 10 and 5.
So remembering that that 1 in 15 is a 10 critical, right? Great. There are other hands raised. Becky, I think you had your hand raised?
Oh, no.
Oh, okay. Kit, go ahead.
Paying attention to relationships between numbers is helpful because you can find products by using those relationships. For example, when I did that times 5 was half of times 10.
Forgot why it was helpful? Between numbers is helpful because
You can find products by using those relationships.
used to find products. Okay. And then your example is right here. Here is a critical relationship for this strategy. Great. Actually, if you think of our noticings, we had a relationship as well. Which I don't think we used. That's fine. We didn't use it, but there was a relationship there. Anybody else would like to share on reflection? Does anybody have anything that is different than these?
I was using this cue, I don't know whether that makes sense. So paying attention to patterns in numbers is helpful because it makes it easier to find the area of a given shape.
So you were trying to generalize beyond relationships, breaking the numbers apart. You were describing those as patterns. Cool. Great. So therein ends the second example.